Well, now that you've watched that video, you've got sort of an idea about this idea of partial pressure. There's the URL for the simulation if you want to go there and play with it. I think it's fun, but you know me, I love this stuff. So now I've got this vessel here with some total pressure, and I have particles B bouncing off the wall and particles A bouncing off the wall. And now we have this idea that, like, oh, it's the A particles are producing their own pressure, and the B particles are colliding and producing a pressure independently. So this mixture of gases, it doesn't care what else is there. Each gas sort of acts on its own to produce a pressure. Well, frankly, I'm not going to do much of the math. There are a few math problems in the homework. They're really extra credit, but the math is not too hard if we don't think about formulas and stuff too much. So here's my vessel again with a ratio of, what do I have? 3 A's for every 7 B's. And I've got some actual numbers here. Now I have a typo. I don't know how I had that. I must have changed this. But if I could measure the gas pressure from A, and it turns out it's not too hard to get a sensor that will detect only one gas, I would have measured 60 ATM. And B, I'm measuring 140 ATM. So I could have 2 sensors on that tank. One's measuring A, one's measuring B. And gosh, if I add those up, I get 200. Gee, look at that. That's what the dumb pressure gauge. Pressure gauge doesn't care. It just says I'm measuring total pressure. And so it gets 200. If I have a sensor measuring A and B separately, bingo, their pressures add up to the total pressure. Okay, so we can just say, well, the total pressure, the pressure total equals the pressure from the particles A and the pressure from the particles B. And it says here again, how are the partial pressures related to total? Well, P total equals PA plus PB plus PC. However many gases I have, just add them all up, or each of them has an individual pressure. Now, here's something else to think about. It says, how are the moles, number of particles of each gas, related to something called the total number? Well, if I wanted to know the total number of moles, well, I'd have to add up the moles of A and the moles of B and the moles of C and so on. No big deal. Well, of course, if I have some number of moles of gas, I'd have to add all the different ones up to get my total particles. My total pressure is the individual pressures. Now, that sort of hints at where we're going. I don't want to get too hung up on any formula or anything. But here I've got a pressure inside the lungs of a patient, nitrogen pressure, oxygen, carbon dioxide, and water vapor. And it says oxygen is 100 millimeters of mercury. My total, if I were to add all these up, 573 plus 100 plus 40 plus 47 equals 760 millimeters of mercury. That's the total of all those individual pressures. Now, I've got a sensor that says oxygen is 100. And it says, what's the percent of oxygen in that mix? Now, maybe stop the video and think, okay, wait a minute. If I know the total, and I know the pressure from oxygen, would it be easy to sort of figure out the percentage? So stop the video and think about that for a minute. All right, you figured it out, right? You said, well, wait a minute. If the pressure of oxygen is 100 and the pressure total is 760, well, that's what? I did the math here. Did I do the math? 0.132. If we converted that to a percent, 13.2%. 13.2% of the total pressure is from oxygen. Guess what the percent oxygen is? 13.2%. So if oxygen's 13.2% of the total pressure, oxygen is 13.2% of the total number of moles, or of the mixture. Now we have a nice little graphic here from this problem. It says what I've got helium here and xenon there. And it says my total pressure is 760. And it says, well, could you figure out from that total pressure what the pressure from helium and xenon is? Well, xenon, it looks like I've got 4 particles. Helium, 1, 2, 3, 4, 5, 6, 7, 8. Now stop the video and think, okay, well, wait a minute. If I know 8 out of 12 are helium, and the total is 760, well, what would the pressure from helium be? There's a number of ways to do that. So stop the video and think about that. All right, you figured it out, right? You said, well, gosh, if the number of moles of helium are 8 out of the total number, say, well, that's 0.666 blah, 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 7. That's the ratio of moles of helium to xenon. Say, well, wait a minute. I'll bet the pressure of helium over the pressure total is probably equal to that 0.6667. And to do the math, pressure of the helium is 500 millimeters of mercury. Now again, there are some homework problems that are like that. They're extra credit. I'm really just trying to get you to realize that individual gases act independently in terms of their pressure. It tells us something about the mix that's there. All right, we are going to completely switch gears now. The rest of this chapter will be talking about liquids and solids only. Thanks for hanging in there. Bye for now.